Okay, so let's continue where we left off with the electron transport chain and oxidative phosphorylation. Again, this is not a metabolic pathway per se. Okay? This is, you want to think of it as a process. What is the function of that process? If you don't know the answer to that, there's no point in knowing any of the details. Okay? You really have to ask yourself, what is the function of electron transport chain and oxidative phosphorylation? I'm going to tell you the function if you can't answer it. The function is to take all these high energy molecules produced in the course of catabolic processes like pyruvate dehydrogenase, the TCA cycle, producing NADH and FADH2. These are electron-rich, high-energy molecules. However, as produced, they're not easily usable. In order to get their energy, you want to oxidize them, with oxygen being the final acceptor of those electrons. And in that process, you are able, because of that process, you are able to sort of usurp their energy and convert it into ATP, a usable form of energy. Okay? So when you ask yourself, why do we need ETC and oxidative phosphorylation, electron transport, you should be able to answer that. That's how we get the conversion of the energy from NADH and FADH2 into a usable form that the cell likes as an ATP. Importantly, NADH and FADH2 produced by pyruvate dehydrogenase, the TCA cycle, and fatty acid beta oxidation are released in the mitochondrial matrix and would have direct access to the electron transport chain component in the inner mitochondrial membrane.